Assalamualaikum warahmatullahi wabarakatuh. So I would like to explain about converting expression using stack. So this is myself. I am Raja Nonafisa Saida binti Raja Kamarudin. Let's get started. So what it is a common algorithm in computer science and mathematics used to convert between different forms of arithmetic algorithm. So there are three types of notation. So firstly we have infix notation. This is a typical form of expression with the operator insert between the operand. So this is example. We have operand A and plus is the operator is between the operand B. So that is the example. We can see that. So the next is postfix notation, whereas the operator comes after the operand. So example like A, P, then next after that operator plus. Then that is a postfix. And then lastly is prefix. The prefix is about the operator first, after that operand. So just like that, plus then AB. That's a prefix. So let's go. I would like to give one conversion example about infix to postfix. So there are a little step to do. Firstly, we need to scan the infix expression from the left to right. Then push operand directly to the output. Next, push operators to the stack based on precedence and associativity. Then lastly is pop operators from the stack to the output whenever an operator of lower precedence of equal precedence is encountered. So let's get some example. I will give some example to this. So we go to the note first. We make a new note. So firstly, this is about infix to postfix, right? So we write first infix to postfix. Then I would like to give some expression like or equation. We have A multiply P plus C and close, then minus D slash E. So this is our infix notation, infix equation. So stage 1, then I would like to draw the stack so we can see how it's a push and pop. Okay, so this is a top. So normally this is null and this is stack. We call it stack. And for easier to understand, we need to do this infix notation so that we can easily do for the conversion to postfix. Postfix notation. Alright. Then firstly, we need the first stage is we need to see this first from the left to the right. So we see the first token is operand A. Then operand A are appended to the output as E. So it means we put A to the postfix notation. So we change the color. We put the red one and we put A here. There's nothing to do after that. So the next stage is this, which is a multiply token, right? So there are, since the stack is empty, it is So the operator, is called an operator, push to the stack. So we put the operator here. Alright. Then we have here only have open parentheses, right? So I forgot to put right here. So we write P plus C close TE. Alright. So this is our current stage. So the next stage, if we have what this is open, right? So open is we need to put but when another operator is to come on the top of this, then then its presenter is list. So we put on top of the multiply operator. So we put it here, right? So we need to erase this. Okay, right. Okay. The next token is B. So we have token B. Then the token is operand, which will go to the output expression, which is postfix notation. So we will write post B is here. So we erase here. So right. The next is stage 6. Stage 6, we have the next token is plus, which is operator. So we put the operator is the next on top of this. So we write plus. Okay. So the plus get pushed into the stack. Alright. So we erase this plus. Alright. Okay. Next token is C. C is the operand. So operand, as we know, we go to the postfix notation, which is output. So we have C here, and erase the C operands. Alright. Then after that, we have what? We have the next token is this, which means that pop all the elements from the stacks and append them to the output when it close, right? It's closed. So expression till pop all the elements from stack and append them to the output expression till we read an opening parenthesis. So right. So it means that pop all element here, pop, right? Sorry, put the element in a stack. So we put once we find this symbol. So we write so we write plus. So sorry, it's not all, right? It's just until we'll find the open. Until we find the opening parenthesis, which is just a plus, right? So there are just plus. So we just write plus here. So the opening parenthesis is don't have. It just go out there. So just write. So that's the postfix notation is there plus. Alright. So next we have so we have the minus D, right? So the next token is a minus, is an operator. The presenter of operator on top of the stack multiply, this is the on top of stack multiply, is more than that of minus. So we pop multiply and append it to the output. So we pop the multiply, so we pop here because multiply is more than minus. So multiply is go to the output and minus go to the stacks, right? Okay, so here Then the next operand is D, so we know D is just like that, and we close the D is then same as we know that D is the next stage. We just go there and see here, and then the last is E, and we just know E is just go there, and then we close this. So inverse notation is gone. So the input expression is complete now. So we pop the stack and append it to the output. So the final answer is, oh sorry, there's a no space there. So I will put this here and here, right? So that is a for infix and infix to the postfix. So the next example, I would like to go to postfix to infix. So there are this step. There is just a different steps. So first, scan the postfix expression from left to right. For each operand, push it into the stack. For each operator, pop the appropriate number of operands from the stack and combine them with the operator and push the new infix operation to the stack. So let's get some example for that. We make a new notes. So this is a postfix, right? So in the color postfix to infix. Alright. So we have example is, for example, we have A B C slash minus A T slash E minus multiply. So we have we draw the stack just like before. This is stack as we know. And then first the operand we can see as A. So A, we just, as we know, just like before, we just put the A here, right? Then we have the next is we have B. So we just put B here. And the next we have C, so we put C here. Then after that we have this is we call this is operator. So when we come to operator, we need to pop two operation from the stack. So we need to pop two expression from the stack. So we need to pop two expression, which is two expression is C and B, right? Pop two expression. Then we only have A in the stack, right? Then in this stack we just like to combine. So we have B slash the operator that before the slash operator and B and C, right, that we combine just like that into the stack. Next we have minus. So we have minus is an operator also, just like the slash, right? Okay, so operand 1 is equal to BC, and operand 2 is A. So push operand 2 operand 1, for example. So we need to push this so we push this to the here. So we have A minus B, just like the group, right? C and close and close. So postfix is just like the grouping, combine when you find the operator, right? So next, if we have the next operand, we have A. So A is, we just put the A here, and then we have D, just put the D here, right? And then we have slash that. Slash slash, just like we do that, we need to combine 2 and 3 and 2, right? Combine this. So we have here is A slash D. Okay, so we have A slash D. So then we find the operand E. So we put E here. We put E here, and then we find the minus, right? We find the minus operator. So which is we need to combine all of this. So this will be I will do the stack again because it is just small. So we read just like this. So open A minus open B slash C close, we multiply with open A slash D minus with E close, right? So all the upper stack we don't have it, so raise is on. Okay, so that is the answer for the minus and multiply. So that's all from me. Thank you. Oh, sorry.